Okay friends, welcome to Login Science. Today's video will be about linear functions grade 12 or straight lines graphs grade 12. Okay, before we can talk about linear functions, we are going to see what is a function. Okay, what is a function? A function f from a set A to a set B is a relation that assigns to each element x in the set A exactly one element y in the set B. Okay, let's say for example you have this diagram. This is a set A and this is a set B. Okay, for this to be considered a function, you can see each element x in the set A is matching up with only one element in the set B. So this is your y in the set B and this is your x in the set A. So there are characteristics of a function which we have to look for. So we have the characteristic of a function from set A to set B. So the first characteristic is that each element in A must be matched with only one element in B. Okay, if you look at the drawing above, you'll see that each element in A is only matching with only one element in B. You can see, for example, 1 is matching with only 9 and 2 is matching with only 13. You can see all of them, they are matching up with only one element in B. Okay, you will not see, for example, 1 matching up with 9 and again 1 matching up with any other element. Okay, it's only matching up with one element, all of them, only one element. So this is one characteristic of a function. Okay, and the second characteristic is that some element in B may not be matched with any element in A. For example, you can see these elements in B, they are not matching up with any element in A. You can see 1, 2, 3, 4, 5, 6, 7, 8, 11, 14, 16. These elements, they are not matching up with any element in A. Okay, this is fine. This is one characteristic of a function. A third characteristic is that two or more elements in A may be matched with the same element in B. Okay, let me read that again. Two or more elements in A may be matched with the same element in B. For example, you can see 3 is matching with 15 and 4 is matching with 15. This is okay. Two or more elements in A may be matched with the same element in B. This is an example here, right? 3 with 15 and 4 with 15. As long as each element in A must be matched with only one element in B. So 3 with only one element and 4 with only one element. Okay, this is one characteristic of a function. And the fourth characteristic and the last one, an element in A cannot be matched with two different elements in B, right? An element in A cannot be matched with two elements in B. For example, you have this element matching up with two different elements in B, like 1 with 9 and again 1 with 13. No, it is only matching up with one element only. Okay, so these are the characteristics of a function you have to look for if you want to identify a function. Okay, now how to tell that a graph is a function. Okay, let's see how you can tell that a graph is a function. Let's say, for example, you have the Cartesian plane, you have your x-axis and you have your y-axis. And on the Cartesian plane, you have a line. So this is a graph. Is this a function? How can you tell that this is a function? You can see for each element, the element on the x-axis. So these are your x and these are your y. For each element on the x-axis, the element is matching up with only one element on the y-axis. For example, you can see 1 is matching up with 6 only, and you can see 2 is matching up with 8 only. You can carry on. You'll see that each element on the x-axis is matching up with only one element on the y-axis. So this is a function. This line is a function. And there is a way to test this. For you to test this graph, if it is a function, you have to use the vertical line test. So you have to use a vertical line like this, in this case, you can see if this vertical line is only intersecting the line once, like one time, so this line is a function because the vertical line is only cutting the line once only. So this line is a function, okay? This graph is a function because the vertical line intersects it only once. You can see only once, okay? This is what? This is a function. This is how you can test a graph to see if it is a function. Okay, and let's see about this one, if it is a function. So you have the following graph, right? This is a parabola. Is it a function? You have to test it. Before you can test it using the vertical line, you can see that each element on the x-axis, so your x is only matching up with only one element on the y-axis. Your x, for example, you have 1, which is matching up with only 1. You can see 1 is not matching up with any other element beside 1. You can also see 2. If you look at 2, this is 2. 2 is matching up with only 4. You can see, right? 2 is not matching up with any other element. So it's matching up with only 4. Even 3 is matching up with only 9. And to test this, you can use the vertical line. You can see if you use the vertical line, it's only cutting the graph once at that point. Okay, you can take it and put it anywhere, right? It will only cut the graph once. Anywhere you put it, it will cut the graph only once. So since it's cutting the graph only once, this is a function, right? So you can say is a function because the vertical line intersects it only once. You can see the vertical line is intersecting it only once at that point. You can see that point. Okay, so this graph is a function because the vertical line intersects it only once. Okay, so we call this the vertical line test. Okay, you use a vertical line to see if a graph is a function. If the vertical line is intersecting the graph once, that graph is a function. Okay, this is called the vertical line test. Okay, what is a vertical line test? A graph in the xy plane is a function if and only if the vertical line intersects the graph once. Okay, let's see another graph and see if it is a function. Okay, how to tell that a graph is a function. Let's say you have your Cartesian plane and you have the following graph, right? This graph in black. Okay, is this graph a function? Okay, before you can decide that this graph is a function, you can see, for example, 9. 9 is matching up with 3 in the y-axis, you can see. And 9 is also matching up with -3 in the y-axis. So you can see your x, which is 9, is matching up with 2 elements in the y, right? 9 is matching up with 3, and again 9 is matching up with -3. So 9 is matching up with 2 elements. So you can see that this is not a function because for this graph to be considered a function, each element in the x-axis must be matched with only one element in the y-axis. You can check for all these elements. They are matching up with 2 elements in the y. All these elements, you can check them. Okay, so when you use the vertical line test, for example, this one, you can see the vertical line is cutting or intersecting the graph twice. It's cutting there and there, or it's intersecting there and intersecting there. So this graph is not a function because the vertical line intersects it more than once. You can see that. Okay, so once again, what is the vertical line test? A graph in the xy plane is a function if and only if the vertical line intersects the graph once. Only if the vertical line intersects the graph once. In this case, the vertical line is intersecting the graph twice, there and there. Okay, so this graph is not a function, as you can see. And now we move on to our topic of today, which is linear functions or straight lines graphs. Okay, we start with the equation of a linear function. Okay, the equation of a linear function can be given in the form slope-intercept form. Okay, the equation of a linear function can be given in the form slope-intercept form. This is the form y is equal to mx plus c. Okay, this form is known as the slope-intercept form, right? Because you have c there, which represent your y-intercept, and you have m there, which represent your slope or your gradient. Okay, so this form is known as the slope-intercept form. Okay, this is what? This is your slope or gradient. So your m is your slope or gradient, and c represent your y-intercept. And another form of an equation of a linear function is the point-slope form, right? The point-slope form. This is the form, this one, y minus y1 is equal to m, in bracket you have x minus x1, like this. Okay, this form is known as the point-slope form, right? And you have your m, which is your slope or your gradient. So this is the slope or the gradient. Okay, now we move on to the gradient or slope of a linear function. Let's see what is the formula to find the gradient or slope of a linear function. Okay, you are given the following Cartesian plane with this graph, which is a linear function or a line, right? How can you find the gradient of this line? Okay, let's say you are given 2 points on the line. So you have this point, which is known as point P, and you have another point, which is known as point Q. So you are given 2 points on a straight line, right? How can you find the slope or the gradient of this straight line graph? So you have this point, it got an x coordinate, which is there. This is 1, right? The x coordinate of the point P is 1. Let's call it x1 because it is on the x-axis, right? And it's got the y coordinate on the y-axis. Let's say it is 3, right? There, and let's call this y1. So the coordinate of point P are 1 and 3, or you can say they are x1 and y1. And you also have the coordinate of point Q. You have 7 and 9, right? 7 on the x-axis and 9 on the y-axis. So let's call this point x2 because it is on the x-axis, and let's call this y2 because it is on the y-axis. So this is your point 1 and this is your point 2, right? The first point and the second point. Okay, so you have to understand that if you want to get the gradient or the slope of a linear function, you are going to need this, the change in the y over the change in the x, right? You have the change in the y and the change in the x. Okay, the change in the y is known as the rise because you are rising, right? Rising, you can see rising. So this is known as the rise, and the rise is equal to y2 minus y1, right? y2 minus y1 because it is the change in the y, and this change in the x is known as the run. You are running, right? You are running, and you are rising, 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 running. So the change in the x is known as the run, and the run is equal to x2 minus x1. Okay, if you have values, as in this case, your run will be 7 minus 1, and your rise will be 9 minus 3. So you have your change in the y and your change in the x. And so the gradient or the slope, we use the letter m. You can see m, you have m there, which is the slope or the gradient. So the gradient is equal to the change in the y, which is the rise, over the change in the x, which is the run, right? This is the formula. So this is equal to the change in the y over the change in the x, right? This is the change in the y over the change in the x, your run. Okay, run is equal to change in the x, rise is equal to change in the y. Okay, or you can say this is equal to delta y over delta x. Okay, this is also the change in the y over the change in the x. So you can say that m, the gradient, is equal to this y2 minus y1. This is your change in the y over x2 minus x1, right? This is your change in the x. When calculating the gradient or the slope, there is an order which we have to obey in order to get the correct answer. You can see when I start from 2 to 1 in the numerator, I do the same in the denominator. You start from 2 to 1, okay? If you start from 1 to 2, you must do the same in the denominator from 1 to 2, right? Do not swap around the numbers. You have to obey this order so that you can get the correct answer. From 2 to 1, and then you have from 2 to 1, or from 1 to 2, even down there you must have from 1 to 2, so that you can get the correct gradient or the correct slope. Okay, you have to obey the order there. Okay, another issue that you may encounter is that if you are not given any 2 points on the straight line, how can you calculate the gradient or the slope? Okay, let's say, the gradient is equal to, how can you get the gradient or the slope if you don't have any 2 points on the straight line? Because you know that to get the slope or the gradient, you need any 2 points on the straight line. But what if you are not given any 2 points on the straight line? Okay, and you are only given an angle of inclination. An angle of inclination is the angle formed between the line and the positive direction of the x-axis. Okay, this is the positive direction of the x-axis and this is the line. Okay, you have this angle between the line and the positive direction of the x-axis. The angle is known as the angle of inclination. So if you want to get the gradient or the slope, you take the tangent of that angle, and then you have your gradient or the slope. Now we look at the types of lines, right? We have increasing lines or rising lines. Okay, you have to understand that increasing lines or rising lines have gradient greater than 0. That is positive. Okay, let's say you are given a Cartesian plane. You have your x-axis and you have your y-axis. Okay, and you have this line which is rising. You can see the line is rising or the line is increasing. You have to know that the gradient of these lines is greater than 0 or positive. Okay, whenever you are trying to calculate the gradient of a line which is increasing or a line which is rising, you have to understand that the value will always be greater than 0 or positive. So if you happen to get a negative value, a value that is less than 0 for these types of lines, you have to understand that you are doing something wrong in your calculations. Okay, and we have decreasing lines or falling lines. Okay, you have to understand that decreasing lines or falling lines have gradient less than 0. That is negative. Okay, let's say for example you have a Cartesian plane, you have your x-axis and you have your y-axis. You have this line which is decreasing or falling, right? You have to know that the gradient of these lines is always less than 0. That is negative. Okay, so if you happen to calculate the gradient or the slope of these lines, the lines which are decreasing or falling, and you happen to get a value which is greater than 0 or positive, then you have to know that you are doing something wrong with your calculations. You have to check your calculations. Lines which are falling or decreasing, the gradient will always be less than 0 or negative. Lines which are increasing or rising, the gradient will always be greater than 0 or positive. Okay, please check that when you are trying to calculate your gradient. okay? And we have horizontal lines, okay? Let's say you have a Cartesian plane, you have your x-axis and you have your y-axis, and you have this horizontal line which is fixed at 4, okay? It is cutting the y-axis at 4, you can see, okay? This is a horizontal line, okay? The gradient of horizontal line is equal to 0. The gradient of horizontal lines is equal to 0. How is that possible? Let's see. You remember from the previous slide, to calculate the gradient, this is the formula. You have to use y2 minus y1 over x2 minus x1. So you have your change in y over the change in x, or you have your rise over your run. Okay, if you can check from this, the change in y, you don't have the change in y because the line is fixed at 4. In the y-axis, the line is fixed at 4. Okay, so there is no change in the y. You only have the line fixed at 4. So in the y, you have 4 minus 4 because you have the same value minus the same value. There is no change in the y-axis. Okay, this is over x2 minus x1 because you have the change in the x. You have all these values. They are giving you 4, all these values. So you have the change in the x-axis, but you don't have the change in the y-axis. The line is fixed at 4. This is why you have 4 minus 4 over x2 minus x1. Okay, and you carry on. This is equal to 4 minus 4 is 0 over, you have this x2 minus x1, right? And this is equal to 0, right? You can see now the gradient of horizontal lines is equal to 0, okay? And you also have vertical lines, okay? Let's say you have the Cartesian plane, you have your x-axis and you have your y-axis, okay? And you have a vertical line which is fixed at 2 at that point, okay? This is a vertical line. It is fixed at 2. You can see this is a horizontal line. This is a vertical line, okay? So the gradient or the slope of vertical lines is undefined, okay? Let's see that. So when calculating the gradient, this is the formula. You have to use y2 minus y1 over x2 minus x1, okay? So this is equal to, you can see you have the change in the y, all these values, okay? You have change in the y. So you have y2 minus y1, okay, over x2 minus x1. You can see you have the line which is fixed at 2 in the x-axis. So you don't have change in the x. The line is fixed at 2. You don't have change in the x, okay? So you have 2 minus 2. You can see that there is no change in the x. There is only change in the y. In the x, the line is fixed there. This is why you have 2 minus 2. Okay, you carry on. You have y2 minus y1. Okay, over 2 minus 2 is 0. And you know that division by 0 is undefined. Okay, so this is undefined. Anything you divide by 0 is undefined. So you understand that vertical lines, their gradient is undefined. Okay. Now we look at parallel lines, okay? Let's say you have the Cartesian plane. Let's say you have this line which is known as A and you have this line which is known as B, okay? So the two lines are parallel to each other. Two lines that are parallel to each other have the same gradient or the same slope, okay? So you can have a third line. Let's say you have this line which is known as C. As long as the three lines are parallel to each other, they are going to have the same gradient or the same slope. You can even have a fourth line. Let's say you have this line, which is known as D. As long as the four lines are parallel to each other, they are going to have the same gradient, okay? It doesn't matter how many they are. As long as they are parallel to each other, they are going to have the same slope or the same gradient. So we can say that lines that are parallel to each other have the same gradient, okay? Lines that are parallel have the same gradient. So you have the gradient of A, the gradient of the line A is equal to the gradient of the line B. This is equal to the gradient of the line C, and this is equal to the gradient of the line D, because the four lines are parallel to each other. That's why their gradients are equal to each other. So for example, if the gradient of A is 2, the gradient of B will also be 2, and the gradient of C will also be 2, and the gradient of D will also be 2, okay, because they are parallel to each other. Lines that are parallel have the same gradient, okay. Now, what about perpendicular lines, okay? Let's say you have this Cartesian plane, you have your x-axis and your y-axis, and you have this line which is known as P, okay? Let's call this line P, and you have another line, let's call this line Q, okay? The two lines are perpendicular to each other at that point, okay? So the angle there is 90 degrees, okay? Because they are cutting each other at 90 degrees, that means that the two lines are perpendicular to each other, okay? If two lines are perpendicular to each other, then the product of their gradient or the product of their slope is equal to -1, okay? You should take the gradient of this line times the gradient of this line. This is going to give you -1 because they are perpendicular to each other, okay? So the gradient of the line P times the gradient of the line Q is equal to -1 because the two lines are perpendicular to each other, okay? Okay, now it's example number 1, okay? So this is the question. Consider the line AB and line FG with equation 4y plus 5x is equal to 3, okay? A, determine the equation of line AB. B, determine the coordinates of P. C, show that line FG is perpendicular to line AB. Okay, you can see that. So you have the line AB and you have the line FG. The line AB and the line FG are intersecting at the point P. This is the point of intersection between the line AB and the line FG. Okay, you are given the equation of the line FG, which is 4y plus 5x is equal to 3. You have it there, okay? So you have 2 points on the line AB, the point A and the point B. The coordinates are given, you can see. Okay, question A, we have to get the equation of the line AB, okay? Before we can get the equation of the line AB, let's get the gradient of the line AB, okay? So the gradient of the line AB, okay, is equal to, you can see straight away that this is an increasing line or a line which is rising. So you understand that the gradient is going to be positive, greater than 0, because the line is increasing, okay? So if you get a negative value, you have to know that there is something wrong with your calculation, okay? You can see straight away that this is an increasing line. So you expect the gradient to be positive or greater than 0. So the formula that you can use to get the gradient of the line AB is YB minus YA over XB minus XA, okay? So you can also say Y2 minus Y1 over X2 minus X1, okay? It doesn't matter. In this case, I'm using A and B, okay? So you can call this your 2 and this your 1, okay? It doesn't matter as long as you obey the order. You can see I'm obeying the order from B to A. Even in the denominator, I have from B to A. So this is equal to, what is your y? B. This is the point B. Your y is 6, okay? Minus your y A. This is the point A. Your y is -2, okay? Like this, right? Over your x B. This is B. Your x is 4. Minus your x A. This is A. Your x is -6, okay? You can see that. This is equal to, you have 6 plus 2, which is 8, over 4 plus 6, this is plus, right? 4 plus 6, which is 10, okay? And this is equal to 4 over 5 when you simplify, okay? You can see this is a positive value this is a value which is greater than 0. So it makes sense because the line is increasing or the line is rising. Okay, and now the equation of the line in the standard form is y is equal to 4 over 5 x plus c. Okay, this is in the standard form. In the form y is equal to mx plus c. Okay, this is your gradient. Now what you have to get is the value of c. Okay, so you can get the value of c using any point which is on the line AB. So you can use A or B. Okay, let me use B. So the coordinates are 4 and 6. This is your x and this is your y. So your y is 6. I'm going to substitute my y with 6. This is equal to 4 over 5, right, times x. My x is 4. Okay, so I have times 4 there plus c. Okay, and what is c equal to? What is c equal to? When you take this to the left, now you have 6 minus, this is 16 over 5. 6 minus 16 over 5. This is 14 over 5. Okay, you can see. So c is equal to 14 over 5. Okay, and finally, the equation of the line AB is y is equal to 4 over 5 x plus your c is 14 over 5. Okay, this is the equation of the line AB. Okay, we carry on. Now it is question B. Okay, let me draw a line here, right? And now question B. Question B, determine the coordinate of P. P is the point of intersection between the line AB and the line FG, right? So what we have to do is to equate the two equations to solve for the coordinate of the point P. You are going to equate the equation of this line and the equation of this line so that you can solve for the coordinate of point P. You need to get your x coordinate and the y coordinate. Okay, now what is the equation of the line AB? You have it, you calculated it. Y is equal to this, right? This is the equation of the line AB. You have it here. Y is equal to this, right? And you also need the equation of the line FG. It is given, right? You have 4y, you can see it, plus 5x is equal to 3. Okay, but you need to write this in standard form first, right? You have to get it in the form y is equal to mx plus c. Okay, what you can do is to keep 4y on one side. This is equal to, you have this 5x to the right, it becomes negative 5x, okay, plus 3. You divide by 4 throughout so that you can have y only on the left. So you have by 4, you have y is equal to, by 4 you have negative 5 over 4, right, x, plus 3 over 4, right? You divide by 4 throughout so that you can have y only on the left. Okay, now you have the equation of the line FG in standard form. This is the form y is equal to mx plus c. Now you can equate the two equations because they are sharing a common point, which is P. Okay, at that point they have the same x value and the same y value. So you have this equation, right? This one is equal to this equation. Okay, the equation of the line AB is equal to the equation of the line FG. And you carry on. What you can do is to keep this on the left. You take this on the left, right? You take it from the right to the left. Okay, so you have 4 over 5x plus, this becomes plus 5 over 4x. Okay, let's use the calculator quickly. So you take your log terms, right? You have this on the left, right? 4 over 5, and you take this to the left, it becomes plus 5 over 4, right? This gives you 41 over 20. Okay, so you have 41 over 20 x. Okay, these are x's. Okay, because you are taking the log terms on one side, this one and this one to the left. Okay, this is equal to, you have this to the right, keep it to the right, so you have 3 over 4, and you take this one to the right, it becomes negative 14 over 5. Okay, the like terms, this one and this one, you take this one to the right, it becomes negative 14 over 5, and this is equal to negative 41 over 20. Okay, negative 41 over 20. You can see that. Okay, now you need to get your x. What you can do is to multiply by 20 over 41 so that you can have cancellation. Okay, so you multiply this by 20 over 41 so that this 20 and this 20 will cancel, this 41 and this 41 will cancel. So what you do on the left, you also do it on the right. Okay, you're also going to multiply by 20 over 41. Okay, so 20 and this 20 will cancel, this 41 and this 41 will cancel. You can also cancel on the right. You have 41 and 41 will cancel. You have 20 and 20 will cancel. So you only remain with 1, right? You only have 1 here, times x is equal to, okay, so what is x equal to? You have x this side, 1 times x is x. X is equal to, this is 1, right? Minus 1, this is 1 when you do the cancellation. So x is equal to minus 1 or negative 1. Okay, now you have your x. Now to get your y coordinate, you are going to plug this value of x in either of the equation of the line AB or the equation of the line FG. You plug in either of the equation to get your y coordinate. Okay, it doesn't matter in which one. So I'm going to use this equation. So y is equal to, I have 4 over 5 times x. My x is negative 1, so I'm going to plug negative 1 where I have x. Okay, right? This is plus 14 over 5. Okay, and so what is y equal to? This is equal to 2. Can you see that? This is negative 4, right? And this is 14. So the denominator is 5. So you have 14 minus 4, which is 10. 10 over 5 is 2. Okay, y is equal to 2. Okay, and finally, the coordinate of the point P are negative 1 and 2. Okay, these are the coordinates of the point P, the point of intersection between the line AB and the line FG. Okay, and now question C. Question C says, show that line FG is perpendicular to line AB. Line FG is perpendicular to line AB. We have to show that the line FG is perpendicular to the line AB. So you understand that from the previous slide, if you multiply the gradient of the two lines, you have to get negative 1. And if you get negative 1, it means that the two lines are perpendicular to each other. So the gradient of the line AB times the gradient of the line FG is equal to what? Let's see if we are going to get negative 1. If we get negative 1, it means that the two lines are perpendicular to each other. Okay, what is the gradient of the line AB? This is the equation of the line AB. The gradient is there. This is your m, 4 over 5. Okay, you can see it 4 over 5 there. 4 over 5. This is your m, the gradient, right? Times, what is the gradient of FG? This is the equation of the line FG written in standard form, in the form y is equal to mx plus c. So this is your m, right? Your gradient. It is negative 5 over 4, okay? So you have times negative 5 over 4, okay? So this is the gradient of the line FG. When you multiply the two, you can see the 4 and the 4 will cancel. The 5 and the 5 will cancel. So you have 1 and you have negative there. Can you see? So this is equal to negative 1. Okay? You can see clearly that these two lines, AB and FG, are perpendicular to each other. So you can conclude, therefore, FG is perpendicular to AB, because the product of their gradient or the product of their slope is equal to -1. Okay, we are done with example number 1. Now let's look at example number 2, the last one. Okay, now example number 2. Okay, this is the question. Determine the equation of the line, okay, A, passing through the point -4, 3, and perpendicular to 2y is equal to 3x plus 6. Okay, let's start with A, right? So the line for which we want to determine the equation, the line is perpendicular to this line, okay? So we have to get this first in standard form, in the form y is equal to mx plus c, okay? You are given 2y is equal to 3x plus 6. Let's get this in the standard form. What you have to do is to get y on its own, okay? So you have to divide by 2 throughout. So you divide by 2, you have y is equal to 3 over 2, right? X plus, you divide by 2, you have 3. Okay, now you have it in the form y is equal to mx plus c. Okay, now from here you can see what your gradient is. Your gradient is 3 over 2. Okay, let's get the gradient of the line which is perpendicular to this line. How can we get it? Okay, you know that the gradient of this line times the gradient of another line which is perpendicular. So this is perpendicular. This must be equal to -1 because they are telling us that the two lines are perpendicular to each other. So the gradient of this line, m, you can see it is 3 over 2. So you know that 3 over 2, right, times the gradient of the line which is perpendicular. Let's write it like this. This is perpendicular. This must be equal to -1. Now we want to get this, the gradient of the other line which is perpendicular to this line. What we have to do is to multiply by the inverse of this 2 over 3 so that you can have cancellation. What you do on the left, you also do it on the right. Okay, so the gradient of the line which is perpendicular to this is equal to, you multiply by 2 over 3 so that you can cancel, and then you remain with only this. What you do on the left, you also do it on the right. So you are going to multiply by 2 over 3, this -1, you are going to have -2 over 3, right? When you multiply by 2 over 3 on both sides, to the left and to the right, you have this. Okay, the gradient of the line which is perpendicular to this line is equal to -2 over 3. Now you have it. Okay, so the equation of that line in the standard form is equal to -2 over 3 x plus c. Okay, now you need to get your c. When you read the question, they are telling you that the line is passing through the point -4, 3. This is your x coordinate and this is your y coordinate. You can use this point to get your c. Okay, your y is 3. This is equal to, you have -2 over 3 times x. Your x is -4 plus c. Okay, so what is your c? Can you see this is times, right? Negative times negative, which is positive. You have 2 times 4, which is 8. So you have 8 over 3. You take it to the left. Now you have -8 over 3. Okay, so you have 3 minus 8 over 3. And this is equal to, can you see this is 3 times 3 is 9. 9 minus 8 is 1. So you have 1 over 3. Okay, c is equal to 1 over 3. You can do that when you take this. This is 8 over 3. You take it to the left. Now it becomes -8 over 3. And you have plus 3. C is going to be equal to 1 over 3. You can do that. Okay. And finally, the equation of this line, which is perpendicular to this line, is -2 over 3 x plus c. Your c is 1 over 3. Okay. Okay, so this is the equation of the line which is perpendicular to this line passing through this point. Okay, we calculated for question A. Now let's do question B. Let me have a line here. Let me draw a line, right? Now it's question B. Now question B, the question says, determine the equation of the line passing through the point -8, -1. These are the coordinates of that point. And this line is parallel to x minus 2y plus 2 is equal to 0. This is the equation of a line. So we want to determine the equation of a line which is parallel to this line. Okay, so the equation of another line which is parallel to this line, right? Passing through this point. Okay, let's get the equation of this line first in standard form. So you have x minus 2y plus 2 is equal to 0. Let's get it in the form y is equal to mx plus c. So can you see you can take negative 2y, this negative 2y to the right, it becomes 2y, okay? And you only remain with x plus 2 to the left. So you have 2y to the right is equal to x plus 2 to the left. Okay, I can write it like this. 2y is equal to x plus 2. Okay, you have x plus 2 to the left, and then you have 2y to the right. I can swap the side. I can put 2y this side and x plus 2 this side. It doesn't matter. I hope you are not confused. This negative 2y to the right, it is 2y. You only remain with x plus 2 to the left, so I can swap it like this. And now from here, what you have to do is to divide by 2 throughout. Okay, so you divide by 2 throughout. You have y is equal to 1 over 2 x plus 1. Okay, you divide by 2 throughout, you have this. Okay, so this is the equation of this line in standard form, in the form y is equal to mx plus c, right? Now the question is to get the equation of another line which is parallel to this line, and the line is passing through this point. Okay, when two lines are parallel to each other, remember they have the same gradient. Okay, the gradient of the line which is parallel to this line is also equal to 1 over 2. This is the gradient of this line, and the gradient of another line which is parallel to this line is going to be 1 over 2 because they are parallel to each other. Okay, so now the equation of the line which is parallel to this line is equal to 1 over 2x plus c. We need to get our c. Okay, you are told that the line is passing through this point. This is your x coordinate and this is your y coordinate. You can use these coordinates to get what? Your c. Okay, your y is negative 1. This is equal to 1 over 2. Your x is negative 8. So you have 1 over 2 times negative 8 plus c. Okay, what is your c? You can see this is negative 4. Can you see? Negative 8 over 2 is 4. This is negative 4. You take it to the left, it becomes plus 4. So you have 4 minus 1, which is 3. So your c is equal to 3. Okay. And finally, the equation of the line which is parallel to this line is equal to 1 over 2x plus c. Your c is 3. Okay, this is the equation. Okay, now it's question C. Question C, determine the equation of the line through the point negative 2, 5 with inclination of 135 degrees. Okay, remember, if you want to get the gradient of this line, you are going to use the angle of inclination. So the gradient of this line is m, right? This is equal to the tangent of 135 degrees, and this is equal to negative 1. You can check it with your calculator. It's negative 1. Okay, now you have the gradient of the line passing through this point with inclination 135 degrees. Okay, so this is the gradient. So now the equation is negative 1 is the gradient. You have negative 1 times x, so it's negative x plus c. Okay, your gradient is negative 1. Okay, now you need to get your c. So you can use this point to get your c. This is your x, negative 2, and this is your y, 5. Your y is 5 is equal to negative x. Your x is negative 2. Okay, negative x. Your x is negative 2 like that, okay, plus c. What is c equal to? You can see this is 2, right? Negative, negative 2, this is 2. You take it to the left, it becomes negative 2. Now you have 5 minus 2, which is 3. So c is equal to 3. Okay, and finally the equation is y is equal to negative x plus 3, right? Your c is 3. Okay, so this is the equation of the line passing through the point negative 2, 5 with inclination of 135 degrees. Okay, this is the equation. And we are done with this topic of linear functions grade 12 or straight lines graphs grade 12. Okay, we are done with this topic. Okay, please check out for part 2 of 6 where I'm going to talk about parabola grade 12. Okay, for now we are done. If this video is helpful, please show that with your likes, comment in the comment section. Remember to subscribe and activate the notification bell so that you can be alerted whenever a new video is posted. Okay, until next time, I will talk to you soon.